Hello. In this lecture, we will look at the informational messages. Information messages are used to exchange error conditions and also notification of delete of security association. If the actual informational message was sent before phase 2 is established, it is going to be in clear text. But if it is after phase 2 was established, it is going to be encrypted. The messages are either notify or delete. Notify messages provide important information related to the error condition, what type of issue exists in the packet. We are going to simulate an error condition, an issue, before and after phase 1, to show you how it's actually seen. For the type of message, we have two octets that specify the message. The messages are defined in the RFCs. The devices exchange 16-bit values for messages. The other side would understand what the 16-bit value means. The security parameter index, there's going to be at least the initiator security parameter index. The responder SPI will not show if the responder hasn't responded yet. The notification data provides the actual message itself. It gives more details about the error. I created an error condition by causing a phase 1 mismatch. Let's see what notification message transpires. If I look at router 1, if I do show run section, crypto. My policy specifies triple DES and authentication of pre-share. In router 2, I have encryption set to AES, so phase 1 is not going to match. So let's see how that will look like. This is before phase 2 gets established. So, this message is going to be in clear text and we will be able to read it. Okay, I am going to run the capture on the interface. Let me initiate the traffic. Alright, so here we see the informational message. If you look at the informational message, it is basically in clear text. The ISA camp header has the initiator and responder. And those are both set up because the initiator sent a message and the responder responded stating that it doesn't like the phase 1 proposal. So, we see exchange type is informational. And then the type is notification. Here, this is the payload length of the notification. And the notification message type is no proposal chosen. So this lets the other side know that hey, your security association transform set is not acceptable to me. If we look at the actual structure of the packet, we will see that there is 20 bytes for the IP header and 8 bytes for the user datagram. And then you have 100 bytes. That basically includes the notification, the actual notification payload. So here, the informational message, we see the exchange type is informational message. And the payload would have more details about what the error condition is. Let's make phase 1 match and cause a phase 2 issue. This way we can see the notification message in case of a phase 2 issue. Let's make phase 2 not match. Let me fix the phase 1. I will make them match on AES. Now both match and we have no notification. We don't have any notification in here. So I'm going to simulate another issue here. I'm going to delete the session. So if I delete the session, there's going to be an informational message that the session was deleted. So there's two types of messages, informational messages as well as notify and delete to clear crypto session. We should see here an informational message. And this is an informational message, because phase 2 was established. It is going to be encrypted. This is an informational message with a delete notification. Let's go ahead and mismatch on phase 2. So I'm going to make the transform set for phase 2 different, ESPAES on one side and MD5 on the other. Okay. So here, we see that phase 1 was completely established. And then phase 2 has an error, since we intentionally cause a phase 2 transform set mismatch. However, because this is after phase 1 keying was established, the message will be encrypted with SKIDE and hashed with SKIDA, and that's why we are unable to read it. But the device would be able to interpret it. We will discuss more in the next lecture.